Hey there, in this video we are going to look at how we clear out fractions. In other words, how we eliminate the denominator in fractions in equations to make our lives a little bit simpler and to make it so that we can just go ahead and solve that equation without any fractions present. So remember that fractions are really a way to represent division. So you can actually multiply each term separated by addition or subtraction, each term by the denominator of a fraction to eliminate the denominator. And again, that's our goal. And this is to eliminate the denominator so that we can have equations that do not have any fractions anymore. So let's take a look at some examples. So looking at number 1 here, we see x over 2 plus x over 3 equals 5. So first thing that we want to do is we want to look at those denominators. And we see two different denominators. And so just pick one of those to start. I'm going to start with 2. And what we're going to do is we are going to multiply the left side of the equation and the right side of the equation by whatever denominator you want to start with. So I'm going to start with 2. So I'm going to multiply by 2. So if I multiply the left side by 2, that means I have to multiply each term. So in this case, each fraction by 2. The right side, there is only one term, just the 5, and that gets multiplied by 2 as well. So to show you the in-between step, we have 2x over 2 plus 2x over 3 equals 10. So we multiply there. Now, the reason we do this is because you'll notice if I multiply by the denominator, in that fraction that has that denominator, so in this case, the first fraction that has the denominator of 2, 2 divided by 2 is 1, and that's just going to be an x. Now, we do still have another fraction. We have 2x over 3, and then equals 10. So now what we want to do is we want to eliminate that fraction. So to eliminate that fraction, we are going to multiply both sides of the equation by that denominator that's still remaining there. So times 3 on both sides this time. And when I do that, I distribute to this first term of x and then to the second term of 2x over 3, and then 10 times 3 on the right side. So we'll have 3x plus 3 times 2x is going to be 6x, and then over 3 equals 10 times 3. 10 times 3 is 30. Now you'll notice because we multiplied by that 3, even though there's a 2 up top, when you multiply by that 3, the 6 and the 3 can be simplified. 6 divided by 3 is going to give us 2. So when you simplify 6 over 3, you get 2. So that means we have 3x plus 2x equals 30. And now we have an equation that's a little bit simpler to solve. So 3x plus 2x are common factors, or common terms rather. So 3x plus 2x is going to be 5x equals 30. And then from there, we see that we have that x term isolated. We just now need to get the x isolated. So to do that, we do the opposite of what's already being done to it. It's being multiplied by 5, so we divide by 5. And if you do 5 divided by 5, you get 1. So that's going to give us 1x equals 30 divided by 5. 30 divided by 5 is 6. And so x equals 6 is our answer on number 1. Let's take a look at number 2. So with number 2, we have a slightly different setup because we do have this x plus 1 on top here, but we still have just an x over here, and we still have two different denominators. So I'm going to start by multiplying by the first denominator of 4 on both sides. And if I multiply by 4 on both sides, I distribute it to each term on the left side, and then each term, the only one term on the right side. So when I do that, 4 times x plus 1, and I'm going to write it out like this, over 4 minus 4 times x is going to be 4x over 3 equals negative 1 times 4, which is negative 4. Now with this, we could distribute the 4 times x and 4 times 1. However, you notice we have a 4 on top and on bottom. Because I have those each on top and bottom, I can simplify 4 divided by 4. 4 divided by 4 is 1. 1 times x plus 1 is really just x plus 1. So we're going to have x plus 1 left in this first term. Minus 4x over 3 equals negative 4. Next thing we want to do is we want to get rid of that 3 as the denominator in that fraction. So to do that, we're going to take both of these sides of this equation and multiply by the denominator that's still there, which would be 3. So we'll multiply both sides by 3. And notice when we do that, we do have to distribute that 3 to each term on the left side and then the one term on the right side. So 3 times x is 3x. 3 times 1 is 3. And then 3 times negative 4x over 3. If we have that negative there, the 3 times 4 is 12x over 3. And that equals negative 12, negative 4 times 3. Notice because we multiplied the 3 to that 4x over 3, this 12 and this 3 will simplify. 12 divided by 3 is 4, so we can simplify that to the whole number 4. So now we just have 3x plus 3 minus 4x equals negative 12. At that point, just like the last one, we combine like terms. So 3x minus 4x will combine to be that negative x. So we'll have negative x plus 3 equals negative 12. And once we have this, then we go ahead and look at getting that x term by itself. So we are going to get the x term by itself, this negative x, by getting rid of that plus 3. The opposite of plus 3 is minus 3. So we subtract 3 from both sides, and we have negative x equals negative 12 minus 3, which is negative 15. And then once we do that, we see that our x term is by itself, but there is still this negative in front of the x that makes the x not by itself. So to get that x by itself, we need to get rid of that negative in front. Now that negative in front is actually a negative 1, and it's being multiplied by that x. So the opposite of that is dividing by negative 1. And if we divide both sides by negative 1 divided by negative 1 is just going to be 1x. So that simplifies to just an x. And then negative 15 divided by negative 1 is going to be positive 15. So x equals 15 would be the answer for that equation. Now let's look at a slightly more complicated expression. So this time we are not solving for x, but I want to go ahead and look at this expression to help us simplify a little bit with fractions. So we're not necessarily going to be multiplying both sides of an equation in this example because it is just an expression. I can't just multiply randomly as I see fit. I do have to simplify what's given to me because, again, it is not an equation. It does not have an equal sign. But we can go ahead and simplify here at this point. So, for example, I could distribute this 12 pi into the parentheses, but before I do that, like we've done in some of the previous examples, I'm going to look at what's being multiplied here and what's on the bottom here. Now I see the whole numbers in front, 12 and 4. 12 divided by 4 does give me a whole number. When I do 12 divided by 4, I get 3. So I'm going to actually go ahead and simplify this 12 and this 4. 12 divided by 4 is 3. So we're going to have a 3 there. And then pi divided by pi, if I take anything and I divide by itself, it cancels out to just a 1. So this is really going to be 3 times 1 right here for pi over pi. 3 times 1 is just 3. So I have 3 for this front part here, and then I still have I still have times x squared plus 8x all over, and then notice I still have this x down on the bottom. So I'm going to go ahead and start with that. And again, that just helps me to simplify it a little bit so that I can eventually continue to simplify and continue to get a completely simplified answer, hopefully in a simpler way than what you might have done if you distributed that 12 pi. So looking here, 3 out front and the x on the bottom, we can't simplify that any further. So I'm going to go ahead and look at this top part and see, well, is there anything that I could pull out of that x squared and that 8x? And I do see x squared, remember, is really x times x, and then x is just x. So I could pull a single x out of each of those terms. I just can't pull any more than that. So if I pull that single x out in front, that's going to give me a 3x times, and then divide each of these by x when you pull that x out front. And notice when you do that, you do 2 minus 1 by subtracting those exponents. We get x to the first, and then x over x cancels out, so we just have plus 8. And then we have over x on the bottom. Now at that point, we can continue to simplify what's in front here and what's here. Because this is 3x times x plus 8, we can use this factor right here, 3x, and we can simplify it with the factor of x on the bottom. X over x, so this over this, is going to simplify to a 1. Now, 3 times 1 is just 3, so we can just leave that as a 3. And then we still have x plus 8. We do not have a denominator anymore. So even though we did not do what we did on the last examples with the equations where we multiplied both sides of an equation by the denominator, we didn't do that here, but we did simplify in a way to where we were able to clear out that denominator of that fraction because of what was there. Now, that won't always happen, but if you can simplify, a lot of times you can at least make it less complicated, if not completely eliminate that denominator. So at this point, we have 3 times x plus 8. We can distribute that 3. 3 times x is 3x. 3 times 8 is 24. So 3x plus 24 can be considered our simplified version. And it is in standard form because our x term with the first power technically is the highest exponent, and then our constant of 24 is at the end. So as a quick reminder to clear out fractions when we're working with an equation, we multiply both sides of the equation by that denominator. So we'll multiply both sides by the denominator. And if there's more than one denominator, then we'll pick one of them to do first, simplify that on both sides, and then pick the second one or use the second denominator to multiply both sides again by that new denominator or that second denominator. Simplify that. If there was a third, you keep going forth, so on and so on. So that is how we clear out fractions in an equation. If we're working with an expression, we just have to simplify, and if it clears out, great. If it doesn't, then we just are left with what we have in that denominator. So again, that would just be simplifying. And it can be helpful to clear out fractions because it can, especially when we're working with the equations, we can eliminate the fractions so that we don't have to try to add or subtract and get common denominators and all of that. Instead, we eliminate those denominators by multiplying both sides of the equation, and then that helps it be a little bit more simple.